And now I'm pleased to start the main event for today. Today is going to be an ISC 2026 analysis conversation about the most important and exciting announcements, news, and trends that we saw last week in Hamburg, Germany at the annual International ISC 2026 conference. So with that, I'm going to ask Antonia, Bob, Valerie, and Rio to all come online, open up your cameras, and let's give them a round of applause and welcome them to the virtual stage. Thanks, guys. So happy to have you all here. I want to save time. Your bios are on the website, so I'm going to ask you just to introduce yourselves very quickly in the order on this slide. So, Antonia.
Thanks, Jay. Yeah, I'm Antonia Marr. I'm an analyst with ISC2026 Research. I'm based in Europe, Frankfurt. And with ISC2026, we cover the HPC and AI market, as well as increasingly more the quantum side. And yeah, since I'm based in Europe, in Germany, I'm also obviously really interested in the topic of sovereignty. And yeah, therefore, ISC was the perfect event for me to attend. Thank you.
Thanks, Antonia. So as you heard, Antonia is an analyst that tracks these advanced computing communities. Our next panelist is also an analyst, Bob.
Hi, Bob Sorensen with consulting firm Hyperion Research. Not only am I the Senior Vice President for Research at Hyperion, but I'm also the Chief Analyst for Quantum Computing and also the resident graybeard at Hyperion and in most of these panels as well.
Welcome, Bob. Valerie.
Hi, Jay. So pleasure to be here. I'm Valerie Taylor. I'm the Division Director for the Mathematics and Computer Science Division here at Argonne National Laboratory. And so my research is in energy efficient computing, also in microelectronics. So thank you. Glad to be here.
Thank you, Valerie. And last but definitely not least, I'd like to introduce Rio Yokota, who is the chair of next year's ISC 2027 conference. And he deserves an extra bit of applause because he's calling in from Japan at about 1 a.m., I think. So Rio, thanks for joining us. Do you want to introduce yourself real quick?
Yeah, hi, I'm Rio Yokota. I'm a professor at the Institute of Science Tokyo and also a team lead at RIKEN. And yeah, it's good to be here, although yeah, it's very late here in Japan, so sorry if I sound a little bit sleepy.
Rio, we really appreciate you being here. And I think the last question is going to be a really good one for you to close us out on, as you know. But we're going to jump into the first question. I have shared my questions with the panelists ahead of time so they'd have a chance to think and provide very concise answers to these. We're going to try to get through as many as we can today. It is a global international conference with 4,000 attendees and a huge technical program. It set all kinds of records this year, which tells you a lot about HPC, AI, and quantum computing growth. But let's start with the big one. For those of you who are not familiar, there is a so-called top 500 list of the most powerful supercomputers in the world. And we have a new #1 this year. It's called LineShine from China. So after years of US leadership, at least in this published list, China entered a new system that is #1, and it is not based on accelerators. It is a straight CPU system. I'd like to get your initial concise reactions to that new #1 system. Bob, let's start with you on this.
Yeah, just a couple of quick points to make on this. The first one is, as you said, it's been 2017 since the Chinese actually reported. So when people say, oh, the Chinese are back, no, they never left. They just stopped reporting on the top 500 list. I strongly suggest this is simply yet another generation of really well-designed systems. And the other thing I'd like to point out is it's CPU only, which means that in some sense, this is a HPC science and engineering dream come true for many people who are still not GPU centric, not looking at AI, and just really love 64-bit floating point. I would love to find out how much the system actually costs, because if we look at what those kinds of systems cost in the US today, they're out of the price range of just about everybody. So fascinating machine. Thrilled that someone is looking at 64-bit floating point as the base architecture for science and engineering workloads. Don't think we're going to see a lot of machines like this. People just aren't going to have the price point to replicate a machine of this size and quality.
Antonia, you want to follow up on that?
Yes, I'm happy to do so. I believe the architecture to the people who can go deeper on it, but if I look at it from a market read, I wouldn't say the real headline is CPU beat the GPUs. I think that there's no longer a single dominant path to leadership class computing, and that's also what the top 500 said in their own release. I think what's more important is that, or more interesting, is that LineShine is almost entirely indigenous Chinese stack, so their own ARM-based CPUs, etc. And I read this less as a benchmark result, but more as like a sovereignty statement. So almost like, yeah, we can build the whole thing ourselves. And yeah, this is what I read from it and why it's so interesting to me.
I love the two analysts hit on several points there about FP64, about CPU only, about indigenous technologies and the move towards sovereign large-scale systems. And Bob, of course, hit on the uniqueness of that budget scale as well. Valerie and Ria, what do you think about this from a researcher perspective?
Right. So I just want to add too, in terms of looking at it being domestically developed CPUs, it really advocates for the case or presents a strong case for a co-design approach. And that is looking at hardware, software co-design. So on the research side, from the co-design, you're going a +1 there in terms of what they were able to achieve with the LinPact, with the co-design. And I think time will tell to see how things work out with respect to AI-enabled applications. That was one thing they were noted that's a work in progress with the AI-enabled applications. But definitely a +1 on the co-design.
Rio, anything to add on this before we go to the next one?
Yeah, so, I thought we were the only one with the pure CPU, like only CPU machines with Fugaku, but yeah, now we have a much bigger machine on the top 500 at the top. I think, compared to like the previous Chinese supercomputers, this is a big step forward. I think the machine is well balanced because it's not just the high performance LINPACK scores that's impressive. They're also #1 on HPCG, which tells that this is a well balanced system. And the fact that it's a purely Chinese manufactured hardware, and also the operating system, they have the full stack. So this is a very impressive system, and I congratulate them for this.
Jay, before we go on, I just want to make note that the announcement was made that Jack Dangara and others, including Horst Simon, who may be listening here, have stepped back from running the top 500 list, and it's migrated to being controlled by ACM. It'll be interesting to see what changes they make, what things they keep, and how they evolve the list to make it perhaps either more relevant or some other metrics that I'm looking forward to in the next year or so. So I think I'm excited to see where the top 500 list goes in the next few years.
Great point there, Bob, and I love all those points. FP64 is not dead. CPU-based architectures, CPU-only based architectures, not dead. Sovereign computing is strong, and the quest for more scale continues to grow because big problems require it. Let's move to the second question, this changing vector landscape. So I know that Antonia and Bob keep their fingers on the pulse of vendors and are tracking vendor there as well. We're starting to see more vendor-designed chips. For example, at Google, we have TPUs. Amazon, Microsoft, they're also designing various kinds of, we also have our own ARM-based CPUs. Amazon and Azure also designing their own CPUs and accelerators. Do you see this trend continuing, or is it a trend that is probably limited only to the very largest budget vendors? And Antonio and Bob, I really wanted you two to speak to this one. Antonio, let's start with you.
Okay. So to be honest, I think people are actually asking the wrong question, because the assumption is still that the traditional HPC vendors are trying to become the hyperscalers, and I honestly don't think that they are. And I think that's the right decision, because I mean, we know that you're not going to out Google or out WS AWS, and the hyperscalers will always have an advantage when it comes to building those massive commodity AI infrastructures. So I would say, instead of competing head on, the competition, or they're competing elsewhere, because I mean, I had the advantage that I was able to spend a lot of time walking around the show floor as well, and I deliberately stopped at some of the smaller booths as well, rather than only the platinum sponsors. And I have to say, I saw some really interesting innovations there. For example, if you take spectral compute, they're not building another GPU. They're rather trying to reduce the cost of switching between GPUs by making CUDA applications portable. And I would say that's a completely different way of thinking about competition. Or if we look at semi-dynamics, they're not necessarily chasing peak flops either. They're focused on memory and data movement, which lines up exactly with what we're seeing in our own research, because their memory bandwidth keeps coming up as one of the biggest pain points for buyers. So for me, the story at IC wasn't that everyone is trying to build a better chip, but the story was more about everyone trying to make the whole system work better. And yeah, I think that's a really, really important factor. So when it comes to sovereignty again, as you might realize, I really like to talk about the topic of sovereignty. But yeah, to say it in one sentence, I would say the chip is still incredibly important, but it's no longer enough. I would say the whole stack is the product now.
Bob, your comments on this, the development of more vendor design silicon.
Love it. In the early days, you know, vendors, end users had to take what vendors gave you. This is our architecture. You like 86 or you don't. And that was okay, but workloads were limited by the processor elements. Now we see it the other way. You have a workload that you're interested in. You can find someone that's going to optimize for your particular workload requirements. And you look at let's leave something out. We don't need what NVIDIA is offering on this. Let's go to a TPU. Let's go to somewhere else. There's so much more opportunity now to match your workload requirements with a hardware configuration that optimizes. You're not bringing along any extra hardware, any extra power consumption. That's the good news. The bad news is, are we talking about reproducibility as we move from one to the other? Do we get different results because somebody has a different routine for how you're going to round numbers? Are you worried about vendor lock-in now? I optimize my system for company X. They fall off the wagon. They don't do the trajectory, or they start upping their prices. And so now I have vector lock-in because I just don't have the portability. If I'm a software company, how do I generalize? Do I have hardware agnostic software? If you do have hardware agnostic software, means you're not optimizing for anybody, which means it runs equally poorly on just about everybody's hardware. So there's good sides and there's bad sides. I hope it all shakes out. But to me, it's opportunity knocks right now. And I'd love to see the end users take advantage of this by literally demanding you have to meet our workloads with your hardware, not the other way around.
All right. And Valerie and Rio, I know as researchers, you might have different perspectives on this. Valerie, I think at the Argonne computing data center floor, I think you have one of just about everything there. And Rio, I know Riken has co-designed processors with Fujitsu in Fugaku. So any thoughts on this, the growth of custom silicon from large scale vendors, including cloud providers?
Okay, so I can go first.
Go ahead, Valerie.
Okay, thank you. So I just want to add, so I think, you know, what Bob and Antonio had to say about the trends that we're seeing. Just want to add too, from a researcher standpoint, as Bob was talking about the workloads, I think that's an opportunity for the researchers, especially looking at, again, going back to that co-design, but looking at areas, for example, where there may be a real-time aspect in terms of that feedback that comes up, for example, with automated labs and looking at automation that we saw at ISC, there was a lot of discussion in that space around edge computing. And so I think that's an area too where researchers are starting to look at some application specific in that space to meet some unique aspects about a particular workload. So I think there are opportunities as well as to complement what we're seeing with respect to the vendors.
All right. And Rio, do you have any final thoughts on this question?
Yeah, so I'm interested in two particular technologies. So one is the ability of coding agents to somehow counter this growing performance portability issue.
Yes.
Another one is the emulation to somehow fill in the gap between the precisions between HPC and AI workloads. So, the diverse hardware is mainly aimed towards AI. Most of them are supporting, very low precision. And somehow I'm hoping that, both with like AI coding agents and with emulation algorithms, we can somehow fill this gap.
I am going to use the moderator's prerogative to make final comment on this round. Loved all that feedback. Rio, I especially liked you addressing the AI coding agents because I do think things like our own Alpha Evolve, which we have a session coming up on shortly, can address a lot of those portability performance issues by using AI to find optimal algorithms for different architectures. And our next question is going to lead into the point you made about emulation. So I'm going to jump right into it now. We heard a lot about mixed precision at ISC. In fact, Jack Dungara discussed it extensively in his final presentation of the conference. Rio and Satoshi, who's spoken in this community before, have talked about mixed precision and Ozaki scheme and things like that before. It is clear that there are software ways to emulate the accuracy of higher precision hardware. Where do each of you stand on this? And I'm going to ask you to give us a concise statement, and it doesn't have to be A or B. It could be A and B. But Rio, I want to start with you, and I think I know where you stand on it, but what do you want to tell our audience about the importance of lower precision but higher performance processors and emulation capabilities versus native FP64?
Yeah, so for those of you who are not very familiar with the Ozaki scheme, it's a way to use these lower precision arithmetic units, but to basically emulate higher precision matrix multiplication. And so one of its limitations at the moment is that it's limited to matrix multiplication. And if you use it, of course, you can emulate, higher precision with lower precision numbers for any algorithm. It's just not as efficient for non-gem or non-matrix multiplication algorithms. So this issue can be dealt with from like two different perspectives. I think one of them is to go back to, designing algorithms in HPC from when, flops was the bottleneck to now where like memory bandwidth is mainly the bottleneck. And so we can afford to waste a lot of flops in that sense. Maybe many algorithms can be turned into actual, like dense matrix multiplications if we wanted to, at the, and at the same time reducing the loads and stores, like the data movement. If that's possible, then many more algorithms could potentially benefit from algorithms such as Ozaki scheme. And another way to deal with this issue is, so if you are memory bound already, then so how you can shift this balance between like the arithmetic intensity is really the key. So we should really start thinking about our algorithms in terms of the data movement it's doing instead of like estimating like the complexity of the flops, right? We're very fixated into like measuring arithmetic intensity and the number of operations we do. But instead, I think an optimal algorithm is one that does not do as much memory or like data movement. And so, yeah, I think we need to really change the fundamental way we design our algorithms. And then I think we can benefit a lot from these AI processors.
Thank you,
Sorry,
Rio.
the answer was longer than,
No, that's okay.
than I wanted to.
I appreciated all of that detail. I'm going to attempt to summarize a little bit and then ask for additive comments from the other panelists. So what Rio said, and adding in what Jack said at ISC, there's data movement is becoming the expensive thing. And by reducing the amount of data you have to move, you can make a much more efficient system. So lower precision isn't necessarily a negative. It can be a positive and still be able to emulate, as Rio said, high precision when needed at the expense of more data movement and having to spend more computation on the same operation. So Bob, I'd like to ask you about this next as a market analyst. Do you see a likely bifurcation where we continue to have FP64 for customers who want it, who need it, and who think they need it, as well as continued growth and emulation capabilities to leverage these lower precision but lesser data movement, higher performance processors? And it's going to be sort of a pick and choose based on workload and preference kind of market going forward? Or do you see the AI accelerator plus emulator sort of maybe taking over?
Well, I'm a double E in training, so I really love the nuts and bolts of the technology. And be aware that the 64-bit floating point that came out of IEEE 754, the bottom line there was it just wasn't, here's where 64 bits divide up. It had to do with portability and consistency in floating point computations. They defined how you do addition, subtraction. They have positive and negative zero for good reasons, round to infinity, round to negative infinity. These are all things that matter to certain people, and you just can't throw it out. And so what we see is there's a lot of emulation going on, but a lot of the rules of the road haven't yet been defined. So certain things you're going to have unpredictability. You're not going to have portability. How is NVIDIA's FP64 emulation deal with not a number, overflow, invalid operations? How are those things done? And so there is, I think, IEEE 754 took a decade for it to coalesce because everyone was arguing for everything. I'm concerned that we're going to have a wild west in FP64 emulation. That's going to take a long time before standardization happens. And the other thing is, I actually gave a talk at this at ISC, and my last graphic was two pictures. One was the Satoshi article, FP8 is all you need. Debunking hardware FP64 is the holy grail. And what was interesting is that was matrix multiplies, and it was really about optimizing memory, not optimizing the math. On the other side of the page is from the NVIDIA's technical blog, and let me quote it directly. Dedicated FP64 vector performance remains critical for scientific applications that are not dominated by matrix kernels. NVIDIA has spoken. Right. So there's a lot of work to be done here. It's not a given. I'm not saying emulation can't be used in certain places, but there are people who are going to die on the hill of native FP64.
All right, I love that fiery response to that. We are going to have Bob. We are going to have a future session on mixed precision and about precision in general. I know not everybody on this call is probably familiar with IEEE 754, but we will actually cover that in a dedicated topic coming up soon. Valerie, Antonia, anything to add to what Rio and Bob have said on this?
Just a +1 to Bob in terms of there'll be the science applications that need the FP64. So I'm on the side of the bifurcation. And then you'll have also with respect to the applications that can take advantage of the emulation. But I think a lot depends upon the science that you're doing and the accuracy that's needed.
All right. Let's move on to the next question. And Valerie, I actually wanted to start with you on this since you come from Argonne National Laboratory. And you guys are really on the front line of massive scale science, and you're on the front line of AI for science as well. So long history in simulation-based science, a new leadership position in AI-based science. Tell us a little bit about, as concisely as you can, what exciting things are you seeing in the use of AI surrogates, and how important does simulation remain or not remain in this future with AI surrogate applications? And Rio, I'm going to come to you next on this one as well.
Right. So thank you, Jay. So with respect to the AI surrogates, I just want to note at ISC, there were some really interesting sessions in that space, like the AI for science. And I think one thing that comes up quite often when you start to use surrogates, and that has to do with the uncertainty quantification. I think that's a major part that was brought out in some of the talks that I think is important, that we're also looking at here at Argonne, is looking at that uncertainty when surrogates need to be regenerated, how much error is allowed. So I think that becomes important, but we are seeing surrogates being used in different places, but understanding that uncertainty. And so I also want to note too, there was a lot of discussion too around digital twins with respect to AI. And we saw that especially at ISC with digital twins and how it's being used with facilities, like for our HPC facilities. So just wanted to note AI in terms of the science as well as the facilities.
Yeah, and I'll even add a little note here real quick. Our own WeatherNext models are trained not just on observational data, but on simulation output data, because you can't always get the observational data you need. Right. But if you've got a physics-based simulation that you trust, at least in some domain for some duration, that can provide the training for it. So I love this balance, and thank you for adding that ISC had lots of coverage of digital twins as well. This has been a topic that I've seen sort of in the background on the periphery for many years, but thank you for pointing out that ISC, not only are surrogates coming to the surface, but digital twins are getting more traction as well. Rio, anything to add on this?
Yeah, so interestingly, I originally started out, during my PhD, I was doing computational fluid dynamics. So I do actually come from the simulation field originally, before I started working a lot on AI. So one interesting aspect of, like the conventional way of solving PDEs using computer simulation is that if you think about the compression rate of, all of fluid motion compressing into the Navier-Stokes equation, which, if you think about it, it's compressed to like a few bytes of information, right? That equation itself. And that having that information, and given certain initial and boundary conditions, you can actually generate very accurate fluid motion. So all that information is compressed into that very small amount of bytes. And so if AI is sort of this, if you think about the compression rate, it's still very poor at the moment, right? It's not a very efficient representation. It's not learning like the essence. And if sort of, these PDEs are like the fish, what we really need to teach AI or these surrogates is how to catch that fish, not the fish itself. And so how AI can be trained to, like basically do this kind of mathematical modeling is, I think, the next big jump. And I see that we're getting there with all the new, like mathematical leaps that it's having. I think, even Terence Tao is impressed with the latest capabilities. So, yeah, I'm very I'm looking forward to what's coming next.
Awesome. So I had that question really for the research leaders, and now for the market experts, I am going to ask a different question. Bob, Hyperion at their breakfast shared data about the tremendous growth in the HPC market, and more generally the HPC data analytics and AI market for scientific and technical computing. And you showed very strong growth in cloud HPC. Still not a majority of the market, even close. On-prem is still the majority of the market, but your growth rates in cloud were really high. Obviously, I was happy to see that, but can you speak for a minute or two about what goes into that, and why are you, how confident are you that very high cloud HPC growth rate will continue, and why? And Tony, I'm going to come to you and your firm's perspectives on this after Bob.
Well, yeah, thanks. First off, growth rates can be more impressive when you're starting from a smaller base. So that's, the fundamental reality. The other thing is what we're seeing is organizations in the HPC world are still kind of feeling their way forward into AI adoption, especially AI for science applications. And so they are very hesitant to commit significant amounts of money to procure the hardware that they need to explore it to the extent that they would if it was a traditional kind of classical mod sim workload. So there's this hesitancy of, can we squeeze what we have for AI onto our existing workloads, or can we, and the other thing, of course, is supply chain issues. It's not easy to get a lot of this hardware nowadays. The CSPs are first in line for some of the most advanced capabilities, whether it be from NVIDIA or in-house capabilities. So we see a lot of organizations saying, let's experiment with AI for science applications by starting off in the cloud. And the other thing, of course, is, at some point they're going to start to make the economics decisions. They're going to get out the green eye shades and talk to the grown-ups who write checks and say, where is the cheapest place to do this? That's where I think we're going to see, the idea of how much can AI support your workloads on-prem versus cloud. So right now there's enthusiasm for adoption because of the hesitancy to lay out the budget for AI stuff. And so the cloud is doing it well. And getting back to the earlier point, I think if the custom processors that the clouds offer can give you a significant price advantage, opposed to going out and buying the latest chip from NVIDIA for an on-prem application, you've got a significant price advantage there that makes the cloud model continue to look attractive versus an on-prem counterpart.
And I would add one thing to that, as a longtime on-prem center leader with systems that range from 3 to 5 or even 6 years in life scale, one of the things clouds can bring to it is a much quicker refresh, which might get you that ROI a different way, even with a mainstream processor.
Yeah, especially now with NVIDIA upgrading their chips almost on an annual basis. If I'm buying a system every 6 or 7 years, which is not uncommon now, I'm 4 generations behind.
That's right.
Advanced for an on-prem. I can go to the cloud tomorrow and get access to a chip that is new and has availability. So yeah, you're exactly right. The time issue is a real important determinant in all this.
Yeah. Also, the data center issues, planning modern data centers is much tougher than the air-cooled ones from 20 years ago. Antonia, what is Intersect360's perspective on cloud HPC growth rates compared to on-prem?
I would say I don't really think cloud versus on-prem is the right framing anymore, because what we're seeing is much more workload specific. So if you, for example, have a project that needs infrastructure quickly, then they're moving increasingly towards the cloud. But many of the traditional HPC environments still have very strong reasons to stay on premise. And I would say one thing we see in our own research is that organizations aren't replacing one with the other. They're kind of building portfolios. So the question has kind of shifted from where should we run everything to which workload belongs where. And when we look at Europe again, there's a third axis, the US conversation often skips, and that's data residency and sovereignty, which keeps some workloads on-prem or on a sovereign cloud, regardless of the economical factors. So I would say most companies I talked to in Hamburg aren't choosing a site, they're running a portfolio. Yeah.
Right. And now we're going to move into the quantum area and probably start with Bob on this, but certainly everybody feel free to chip in. I know Bob specializes in tracking this quantum market and attends all the quantum meetings. First of all, Bob and everybody, were you surprised about how many quantum vendors were at ISC 2026? I didn't count perfectly, but it seemed like there were definitely more than 10 on the exhibit floor and lots of talks in the technical program. Did that surprise any of you?
I'm thrilled. I mean, we've seen it, the increased participation of quantum, and it's not viewed anymore as a curiosity. It is now each of the companies, the quantum companies I spoke to, and I think I actually did talk to at least 10 different organizations. Their big concern right now is, hey, we're no longer a science experiment. We are on the early stages of productization. The big concern here, the reason you go to ISC and SC in the United States, is because you want to talk to the people who are going to be the most aggressive early adopters and who have the most concerns about quantum HPC integration capabilities. And if there was a theme of this conference, it wasn't, look at how many qubits we have, or look at how great our modality is compared to their modality. It was, we're looking at integration concerns. We want to be able to walk the walk when it comes to serving specific verticals. Are you an oil and gas company? Are you pharmaceutical? Are you a government research lab? We want to be able to speak your language and integrate into your existing compute ecosystem. That was the message of the day. I saw a talk from a small company out of Paris called C12. They had the spotlight for 20 minutes. They never mentioned their machine. They talked about how that machine fits into the HPC ecosystem. And the guy that they hired for C12 to market their quantum system came from WECA 5 months ago. And I thought, okay, they're starting to get it. They understand where the market's going to be. Hopefully the fights about modalities and T1 and T2 times, all that stuff is going to go away. It's going to be, hey, we've got a workload capability that meets your vector or vertical specific requirements. And we can integrate it, perhaps not seamlessly today, but that's the goal from a software perspective.
And did any of you see any compelling talks where you felt like they really were getting value right now, even out of these noisy intermediate scale quantum systems when used in hybrid configurations? I realize the research is important. It's not all about quantum benefit at the beginning. It's about setting up for quantum benefit when these systems are more fault tolerant, less noisy, larger, et cetera. But did you get the feeling that anyone was making or on the cusp of making a quantum benefit advantage now with a NISQ system in a hybrid environment? Or did you feel like it's close? It's a year or two away, even if it's not yet going to be mainstream usage in a year or two. What was your sort of feeling? Where are we on that hockey stick uptick? Are we at the inflection point? Are we still below that? Are we slightly above it, but not at the maximum gradient? What did you think based on ISC? Rio, did you have a feeling about this?
Well, so I am, not very knowledgeable about quantum computing in general, but I felt the excitement. So surely there was much more talk on quantum than ever. So I feel that there are more and more people interested in the area.
Valerie, what were your impressions?
Yes, I similar to Rio, I thought there was a lot of discussion, especially about the integration of quantum in HPC systems and looking at what's needed, especially in terms of the software stack. So it was really great, I think, with Martin Schultz to start off the keynote talk that was talking about integration and heterogeneity, and quantum was there, as a component of the system that he was discussing and looking at that in the future. So it was good to see the number of vendors. It was also good to see the number of sessions too that was talking about this integration, looking at HPC systems combined with quantum. And I think we're on the cusp of looking at algorithms that truly take advantage of that heterogeneity, because you see that being discussed in so many places. So I think it's an exciting time to look at that component.
Agreed. Antonio, what are your thoughts on this?
I think the best points were already made. I think as well that we're going in a really good direction with quantum, and I think that no one as of now has the opinion that this will replace classical HPC tomorrow. I think people are adding quantum where it generally creates value, and I would say it's a really healthy direction, and especially more healthy than expecting quantum to suddenly replace all existing infrastructure. So, yeah.
Jay, let me just get one quick point in here. I talked to some folks at a software company called Classic out of Israel, and they had just released some work they did with Rolls-Royce. Rolls-Royce, the guys that make advanced jet engines, have been looking at quantum for years now, and they just released a paper that talked about some activities to do computational fluid dynamics using a quantum algorithm, a hybrid quantum algorithm. What blew me away, though, was the analysis at the end that said researchers were very pleasantly surprised that the system worked better than quantum classical theory would have predicted. And they talked about the use of heuristics and rules of thumbs and programming shortcuts that the potential that says, okay, this is what the theorist would say. This is what the guy writing the code gets. And those two things may be fundamentally different as more and more people start to play with quantum and say, hey, I've got an interesting trick. We know the HPC world is filled with shortcuts, and the guys that don't add that in the comment field, and you can't figure out why the code works. I think we're on the cusp of a new generation of innovation from heuristics as more and more people get their hands on a quantum system and say, hey, I think I've got a better way of doing this. And Rolls-Royce was one of the first ones to step out and say that, and I'm hoping we're going to see more of that.
Me too. I think, what is that phrase? Don't let perfect be the enemy of good. I saw a lot of that kind of approach at ISC. A lot of folks that are completely realistic about, it's not about standalone quantum replacing classical, it's about hybrid. It's not about quantum systems being as perfect and not being deterministic like classical systems. It's about hybrid again. It's about finding ways to leverage the strengths of each. And I really, it's such a huge change over the last 2 years from all the excitement about being which modality will even work to people focused on getting work done.
Right.
Let's change the direction a little bit here. Great demographics at ISC. I really love seeing the range of ages, people from all over the world, people from industry and academia and government. But there's a lot of talk about a talent and skills gap in HPC. There's been a lot of talk about this for the last several years. However, quantum, the workforce is growing. AI, we all know there's a huge AI workforce. Whatever its repercussions might be on the rest of the workforce, there's a growing AI workforce. What do each of you think about the talent and skills situation? I don't want to call it a gap unless you think that it is, but do you think we're training enough people in these advanced computing technologies? Are there any areas where we need to do better at training more people fast? Antonia, let's start with you on this. And what is your perspective on the rate at which we're training? And it may vary by technology, by region, et cetera.
Yes, so I would say it changed a lot because we used to train HPC specialists, and now computational scientists is expected to span classical HPC, AI, machine learning, quantum, etc., you name it, all at once. And that's a much wider skill set than the field was built to produce. And I would say you can hire your way out of it because there are simply not enough people. But I mean, what we can do right now is changing our approach a bit as to how we welcome the people into the ecosystem and also get them to stay. So, for example, I'm in the newly formed ISC Next Generation Committee, and one thing we spend a lot of time discussing is how we make this community more welcoming for early career researchers or professionals. And of course, the technical skills matter, but the hardest part isn't necessarily teaching people the technology. It's helping them also build a career around it. So I don't know, for example, finding mentors or building networks and meeting employers. Just giving someone the feeling that there's a place for them in this community. And I mean, IC is putting a lot of effort into exactly those areas. And yeah, I'm happy that I'm also part of it. And when doing this, I mean, it will also hopefully translate on topics like us keeping our talent in Europe and not losing so much talent to the US, which can pay more. Yeah, so I would
All
say,
right.
yeah,
Thanks.
make it possible to keep the people.
Thanks, Antonia. Bob, real quick on this. What's Hyperion's take on the market and the talent surplus gap, whatever it is in each of these areas?
Quickly, this is a great example. HPC needs to be made more cool and more modern. And I remember talking to some folks at NASA. NASA has a perennial problem hiring people, which kills me. And so I looked at one of their vacancy notices, and it was this litany of technical requirements. And it was just so obtuse and obscure. And I said, what is this person really going to do? And they explained what the job was. And I said, so basically, you want to hire someone to figure out how to fly drones on Mars because the atmosphere is different, the climate's different. I said, that's what the job should say. This is a cool thing. This is what brings people. It's not a litany of, has to be familiar with Slurm 6.2 and yada yada. It's make it as exciting as it really is, and you'll get people to come to it. And that's the first thing. The second thing that really concerns me now is this emphasis, this belief that AI can do code generation, and it can do some simple things. But my concern is that the people that enter any of the pipelines in the computational science fields, we're going to clinch off that entry into the pipeline. So yeah, we have code generation for the easy code, but what happens when those people who aren't maturing now, we're not feeding the supply chain, we're not feeding the pipeline to senior analysts, the senior developers and the leadership in the community, because AI threatens to actually choke off that first stage pipeline. And I think we're going to have to deal with that issue going forward, and maybe bite the bullet and say, yeah, maybe code generation works, but we need to be training people how to write an effective triple nested do loop before they can move on.
Yeah, I totally agree with that. And we're going to tackle that topic coming up soon, because I am shocked at how good AI code generation is, and not shocked at how good AI code optimization is. Both topics we're going to address it. However, I've noticed that every time that I try to generate code with AI, the second I get lazy and stop thinking like the software designer in the way that I start the prompting and everything, the code is not good. I still have to think exactly the same way. It really just saves me more of the toil than it does the design. So
right, well, let me just ask the question. So Rio, you guys are moving from CPU only to a GPU for the Fugaku-Next system. How much is your organization going to depend on some kind of code generation or code migration capabilities for some of your, really aggressive legacy codes that have to suddenly become GPU friendly?
Yeah, so we are exactly discussing that topic right now. So I think in the US, back when they introduced GPUs into their supercomputers, they had huge projects like ECP. It was heavily funded, and there was a lot of manpower to do the porting to GPUs because they didn't have AI at the time. So now we are tasked with porting from all these CPU codes on Fugaku to GPU codes on Fugaku-Next. And it's happening at a time when we have this new technology that may make some parts of this a little bit easier. So maybe that comes to our advantage. But I think from the early experiments of trying to use, for very large, like even legacy Fortran code bases, just trying to vibe code all the way to make it run on CUDA is so one of the main things is that the developer should
Rio,
not lose control.
Rio, I am going to stop you there. Bob very cleverly waited for 53 minutes into the hour before he hijacked me, but that's okay. It was a great hijack. But I do want to make sure that Valerie gets a chance to answer that last question. We are going to talk about code development coming up in a future session. But Valerie, I do want to hear what you had to say about the workforce before I ask all of you what you think my first question is going to be for the ISC 2027 recap. So Valerie, comments on that workforce.
Okay, I'm going to be short, and that is a plus on Bob's comment about being more welcoming and not having a litany of a list of things that people need to have in terms of background to get involved in HPC, quantum, etc. So just want to stop there and say we do need to work on the welcoming aspects with our job descriptions, also the things we do in our community with conferences. So it's really great with ISC to have the next generation committee.
Agreed. Thank you all for those answers. Sorry to cut Bob and Rio off on that last one. I promise we're going to come back to that topic in a future session. But I wanted to make sure that each of you have about 30 seconds to share. What do you think is going to be the biggest thing at ISC 2027? What do you think my first question next year is going to be about? Valerie?
Integration. And that is looking at integration with agents, as you have large agentic system, integration with heterogeneous systems. But I'm going to say integration from that aspect. And your question will be, how important was integration at ISC 27?
All right. Antonia?
I think next year sovereignty is going to be a big topic again, but I think next year we'll stop asking who announced an AI factory and start asking which one's actually delivered. I would say the easy part, making the announcement, is basically over. Jupyter's running and the AI factories are funded, so the sovereign projects are real. So the question then shifts from, should we have sovereign AI, to the harder one, are we actually becoming less dependent? Because building the sovereign infrastructure is one thing, and being able to measure whether it's working is another. And yeah, I think that's a big topic we will have next year, or what we will find next year at IC.
Bob?
Well, and I had to agree with Antonia, the sovereignty thing. So I'm going to pivot quite quickly and say, your next question is going to be, how many of you people saw the AI bubble bursting this year? I think that, enterprise world has their own things. I like ordering pizza, talking to a robot. I can accept that. I think AI for science is going to be more measured. It's going to be more thoughtful, and it's going to be introduced only where it adds value. And Jay, I loved your point earlier. The idea of digital twins and what AI brings to the table. To me, as long as people respect it, that's almost a counterpart to empirical data. It's not perfect. It doesn't give you everything. You have to understand the limitations. And I think the science and engineering will look at AI alongside empirical data. It points you in the right direction. It doesn't solve all your problems. So next year, AI bubble bursting for HPC.
Bold call, and I can't say I'm in favor of that.
Prepare.
Oh, sorry. Yeah, I agree with everyone that integration is an extremely important theme for next year. As the program chair, I mentioned in my closing session that connecting the dots was always the theme of ISC, and I'm advocating for connecting the far dots.
Yeah.
Going out of your comfort zone in terms of your background, or just not just a scientific background, but trying to connect with the far dots is what I'm proposing as one of the themes for next year. And yeah, so this aligns with what Valerie said about integration of different disciplines and all the people there. So I hope to have this as the main theme for ISC 2027.